The next speaker is Professor Jinhua Zhao. Jinhua, if you want, you can try sharing your screen. And in the meantime, I will introduce you. So Jinhua is the Edward and Joyce Lind Associate Professor of City and Transportation Planning at MIT. Something about him: he obtained a Bachelor in Urban Planning from Tongji University, and then a Master's in Transportation and City Planning from MIT, followed by a PhD in Urban and Regional Planning at MIT. There, he directs the JTL Urban Mobility Lab and the Transit Lab, and he also leads long-term research collaboration between MIT and major cities worldwide, just to name a few: London, Chicago, and Hong Kong. And also, he has founded and directs the MIT Mobility Initiative. In his research, he brings behavioral science and transportation technology together to shape travel behavior, design mobility systems, and reform urban policies. In general, the research is dedicated to develop methods to sense, predict, and nudge, and regulate travel behavior, and is focusing on designing mobility systems, integrating autonomous vehicles, shared mobility, and public transport. Today is going to talk about transit-oriented MOD policy and system design. This is clearly the great focus of this workshop, and I'm personally very excited to hear more about the subject. So, Juno, go ahead.
Great.
The stage is
Thank
yours.
you so much, Jill, for the introduction. Also, the whole committee, Professor Emily Frazzoli, for organizing this. So I titled this as Transit-Centric Autonomous Mobility on Demand. We'll talk about the system design and policy aspect. Particularly, I want to emphasize the transit orientation, right? So in today's talk, I want to try to basically answer one question. What's the difference between a transit-oriented AV operation versus a generic AV operation here? How does the transit orientation really make a difference here, right? So we have all this technology going on these days, but now for this talk, I want to say there's a lot of technology uncertainty in this. But now I try to bring attention to the system uncertainty in order for this technology to be part of the urban mobility system meaningfully. There are a whole set of system uncertainties I list here, like what's the ownership model? Is a single use, shared use? Is integration with public transit or not? Is there a rational pricing structure? Can it be coordinated to land use, etc.? But today I will focus on the integration with public transit, right? So my talk, I'm more speaking from a perspective of a city planner here. So when we talk about the public transit and integration with shared autonomous mobility on demand. So first of all, why do we do that, right? So start with this very simple concept. We've asked what's the difference between iPad and a trip? There are many different ways you can look at it. But one thing is all the iPad, they look the same, but every trip is different, right? So here, that's why we have all these on-demand services, right? It responds to the dynamic and heterogeneous consumer preferences. But what's missing from a purely demand-driven system is that it ignores externality, a lot of congestion costs, environmental costs, and social costs, right? So the other side, why do we have this mass transit, right? Even though every trip is different, but some trips are similar enough for them to package into a high-capacity mass transit system. That's the economy of scale that reduce congestion, CO2 emission, and improve equity. But what's missing with the mass transit? It does not respond. It does not respond to the dynamic and heterogeneous consumer preferences. So here, between the two sides, if you look at the public transit, economy scale, encourage nodal concentration, have a high capacity, versus autonomous vehicle have a demand responsive, can serve door to door, have an individual comfort. So the question is, can we bring them together here, right? Of course, I only list a few dimensions here. You can expand this discussion to a lot more factor that we should consider in the whole urban mobility planning process. If you look at the route design, from the whole fixed route to the on-demand, in terms of the area served, from a portion of a metro area to the entire area, in terms of the schedule, fixed or on-demand, span of service, vehicle size, trip, service planning, operation, affordability, funding. If you look at all these dimensions, there's a whole spectrum there. And a different transition technology can sit in this multi-dimensional spectrum in different ways, right? So the question here, is it meaningful to have the public transit and shared mobility together here, right? All right, so I'll start with a simple example. That's old research now, many years ago. Well, we started at look at the Singapore as a case. This is their mass transit system there, And if we pay attention to a particular neighborhood called Tampines here, is a large system there. This shows that for each station, how do people access the station, right? There's a bus access, about half, and the other half is about walking there, right? If you pay attention to the Tampines area, the way people access the station, they're walking by half. The other half is by a bunch of buses that gather the demand from the neighborhood and centralize and send it to the station here, right? So look at this. If you pay attention only the red route for now, there often you see the bus route like this. They go around and then they tour around this neighborhood to pick up the demand around the neighborhood and to send to the station. Similarly, this one that goes through here and on. Right, but then we actually examined the situation of the bus services around this MRT station. There's about the 30 route and the direction combination. If you rank them by the number of passengers they actually deliver to the station, you'll find such a distribution. So we helped them to design a system so that for the top half of the bus route, you keep them as it is because they are already efficient, with a high demand, while for the bottom 10%, let's repurpose this bus route while using the AV on demand as a way to serve this scattered demand, right? So therefore, if you look at this, instead of going this line, you can straighten it, improve the bus service while use autonomous vehicle on demand to serve this scattered demand, right? So there are many occasions like this. So you can develop a simulation engine, run it, and then we compared this integrated service. So half on the bus, half on the AV on demand, evaluate it against the passenger level service. This is the walking and waiting time. You can see that with the free size, the auto vehicle time reduces. The yellow one is the status quo. That's if you continue to serve the bus as it is. So when can you design the system so that it's better than the status quo from the passenger point of view? You also can evaluate it from the system traffic point of view, the total BKT, and also from the AV business point of view for it to be profitable. Right. So here, the high level lesson is this: there is an opportunity window exist where the integrated system can be better than along each of the three dimensions, from the better level of service to the passenger, less traffic to the system, and for the AV operator to make money. But this opportunity is narrow, at least in the context we learned. So the integration itself, we cannot take it granted. When you integrate, it will always perform better. You have to do a very active design and a search for the opportunity that way it does improve. So that's one example. But if you think about what are the opportunities there into the synergy, right? That's the first mile access, which is described. There's also there are many cases we have a very low productivity bus route. So can we replace those bus route with this AMOD? And the last one is the most ambitious one. Can we redesign the transit network entirely, assuming that now AV, SCV can be served at the first mile and the last mile demand here? All right, so let me give you the second example. This is in London. All right, here, what do we introduce in London? First of all, in Mayor for London, they have published this transport strategy. Very explicitly says, whatever the new technology, autonomous vehicle, connected vehicle, it has to understand, evaluate the impact on public transport and accessibility, particularly the connected and autonomous vehicle development are used in a way that consistent with this particular policy. So in London, there's a very concrete policy requirement for the SAV's design to be consistent and compatible with the public transit services there. So this is the London's on-the-ground system. And we focus on one particular area called Orpington in the southeast part of the Greater London area. We studied their demand. You'll find there roughly two types. One type of demand is going to the central London via this commuter rail system, the railway system, and the other one is within the neighborhood itself, right? You can look at the current mode share, they differ significantly. For example, the one goes to central London, 74% actually going the railway based, right? Our intrazonal are largely based on cars. So what we did is we from the demand side, we generated the new mode AV plus PD as the integrated mode and reassigned the probability of people choosing between different mode. Here, this one versus in London versus Singapore is explicitly built in the demand responsiveness to this, right? So we are designing the supply system as a new service mode, but we then also embedded how demand will change, respond to this new system. So this is integrated iterative design to illustrate. And you can evaluate again from passenger, AMOD, PT, or authority point of view there. Right. All right. So the first thing I want to mention, the idea was just described of the possibility versus reality, right? There's a lot when Uber and Lyft just came out, there's a lot of kind of ambition of saying that there is a potential for TNC to serve the first mile, second mile of the first mile, last mile of the transit system, right? Instead of just competing with the public transit, right? So we did a study on this. This is more of econometric analysis. We find that on average, the entering of TNC in a particular city in the United States actually increased the road congestion in terms of both the intensity and the duration, and it reduced the public transit ridership by about 9%. So that's kind of a macro level analysis. Here's the result there shows about 9% reduction of public transit ridership with TNC. Then we'll look upon a few specific cities. Here, this is in Chengdu in China, looking at how the Didi's pickup location versus transit pickup location. We find that the large chunk of the trips are directly competing with each other. So there's some more substitution. Then we also look at it in Chicago more carefully. If you look at this graph, the red part is suggesting that the TNC mode and transit mode are directly competing with each other. The blue part is indicating the two are roughly independent of each other. They're not interaction in any meaningful way. While this green line, that's the edge where the TNC is indeed providing the feeder services to the public transit. That's the part that we can argue that's complementary to each other, right? You'll find that overall, this part is very, very narrow, right? So the idea of integrating AV and PT in this way, at least up to now, has not been realized in any meaningful way. It's a very small niche market in this context. So the first part I want to mention, when we talk about the integration, right, what are the dimensions we need to discuss here? I put this in these following categories. The first part is more of the information integration. For that, there's already a lot of attempt to do that. Many apps, startups try to offer this one, to bring the information together. The second one is the pricing and the ticketing integration. Ticketing integration is more of a technology argument there. Can you use the one single instrument to bring multi-mode together? For that, technology is ready. The question is, how do you bring the multiple party interests together so they can use the same media? But the pricing integration is much more challenging. Later, we'll get back to the why it's difficult, because public transit and private SUV services are under very different regulatory regime. The pricing principle are entirely different, right? Here I'll come back to that. So therefore, when you integrate them, under what regime the pricing should be discussed is not even clear there, right? Then there's the operation integration. In terms of, say, how can the SUV service be coordinated with, say, for example, train highway control there, right? Then the network integration. Then beyond that, there's some more high-level discussion on the business model integration and regulation integration, even cultural integration. Let me try to give some example in a minute there, right? So let's start with some more of the planning, scheduling, control side. So if you look at each of the services for rail, there's a timetabling, there's staff scheduling, there's pricing, there's business model. For bus, you have a network design, timetabling, staff scheduling, pricing, etc. You can look at it in each of the mode. You've got different function there, right? You may observing this, you may find there are many opportunities you can integrate in different ways. For example, if you want to look at all this together, can you do this part together? Can you put the timetabling, network design, and cross the rail, bus, and the ride share? So that's one way you think about it. So when the ride share do the rebalancing and the matching, can you consider the feeding bus and rail schedule and timetabling, right? Another example, can you integrate pricing across them, or integrating between business model, etc., right? But let me give a more concrete discussion, particularly look at the governance model here, right? Let me try to show this graph, try to illustrate the different entities and their relationship in this whole urban mobility arena. Let me start with this. So these three indicate the situation where we are only talking about public transit, right? So here there's the conventional public transit operators, be it Transport for London or MBTA or Chicago Transit Authority or Hong Kong. This is the bus and rail operators, right? then they interact in two ways. One, they interact with the riders, right? The other way, they interact with public authority there, right? So public authority provide often a planning and intervention in this. But here, when we introduce this autonomous vehicle, you'll find this picture gets much more complicated. For example, we're putting both on-demand AV operator in this and the AV producer in this. Well, there's a lot of relationship that's new that we should consider. For example, how would the on-demand AV operator and the conventional PT operator interact with each other? Are we talking about they are coordinating with each other, or they are just has a less fair competition with each other, right? And then from the rider side, would the rider then have a richer set of choices between the AV operator and the PT operator, and as well as the potential integrated service there, right? And then from public authority point of view, say, for example, if you sit in the seat of, say, Transport for London or Department of Transportation in certain cities or states, how would you coordinate between the multiple services, right? What attitude did you take? It turns out that in the world, you have a whole variety of these governance models, right? They contrast each other really sharply. Here, this is the Boston, Massachusetts model, right? In which META basically invest, finance, manage, operate, control the price, everything about public transit, right? This is one kind of end of that, right? Then you also find other more interesting mode. For example, in London, TfL as the authority on the railway side, they manage, invest, but also directly run sometimes. While in the bus side, they manage, but they do not directly provide the service. They actually offer a bidding service. So the private bus companies actually bid for the services, right? Then there's a Chicago model, the Singapore model. You'll find there's a variety of possibilities that the system is being governed. Here, how do we think of this government model in the context of this autonomous vehicle, right? So here's just some examples to think about. One way is we really take a laissez-faire approach, right? Whatever private company, be it BMW or Uber or Waymo, they can come into my city, just operate whatever service. That's one possibility. And the government mostly take the responsibility for controlling the safety, the emission, but leave the operation to be the private sectors, right? But the other way is TfL potentially can run a SAV division in-house. For example, TfL, just like the fact they are running a railway service, they manage the congestion pricing, they can also run SAV by themselves. And the third one, a potential more interesting one, is offer a competitive tendering process where TfL govern the overall network over the pricing structure, overall coordination between multiple modes, but invite the private sector to contribute into this process, right? So here I also try to differentiate between, in the United States context, the national government role versus the local government role. In the national government, mostly it's on the safety and emission side, while on the local government, that's where the particulars comes in. Like they mostly run their manage the taxi services, manage the data, manage the local street design, the policing, zoning, road pricing. So here you'll find there's a whole set of a local power that will interact with this. Here, this is the illustration of how you translate these planning principles, like equitable, environmental sustainable, efficient, livable cities, into the particular actions vis-a-vis each of these mobility services through those regulatory mechanisms. For example, through the zoning power, through the policing power, control of the streets, of the design, the transit operation, the taxi regulation, the data management. Through those things, you can translate to, how do you manage each of that? I won't get to the detail, but to say that for the SAV and the PT to really work together well, all those things you have to think through to enable these possibilities, right? So lastly, in the last 10 minutes, I really want to answer this question directly. What's the difference between the transit-oriented SAV operation versus the generic SAV operation, right? I put them into 4 different layers, into the social purpose layer, regulation layer, technical layer, and the behavior layer, right? On the social purpose layer, the highest level summary is very simple. If Waymo comes here offering, say, a shared and autonomous vehicle, as a private for-profit business, they cherry pick the segments and maximize the profit, right? By the nature of this organization. While public transit has important societal duty here, which is private access for all. Those two are very different principles here, right? So when you bring them together, again, under what principle are we looking at this integrated service? Within the social purpose, roughly there are three broad aspects, right? There's a mobility aspect, there's the environmental aspect, and then there's the whole network and accessibility aspect. Yeah. So for that, the mobility aspect, so are we providing access for all? Therefore, even though some portion is not profitable, we still have to guarantee the service, versus I just cherry pick the part that is most profitable and ignore the other parts, right? The other aspect is of whole disadvantaged and disabled group. How do we, to what degree the policy is intervening with respect to the service to this group of people on that, right? So this is the social purpose layer. And then when they translate the social purpose layer to specific regulations, here I just give a high level summary here. Overall, there's a much higher regulatory burden upon public transit than the private sector mobility services on each of the aspects, the equity, the environment, the network, etc. Then in terms of the instrument that the typical government has when they try to introduce this regulation, there are different aspects of pricing, physical control, and market. So let me give some example on that. So I'll just describe a little bit on the pricing, right? So in public transit, in most cities in the world, the pricing of the subway fare and the bus fare is heavily regulated, right? It requires a very like nuanced political process to negotiate the price there. And also most situations are largely dependent on subsidy. While in SAV pricing, the principle is profit orientation or market share orientation, depending on different stages of the corporation there, right? So the dilemma is, if we are introducing this integrated public transit SAV service, under what regime should we even think about this pricing structure here? Is it subject to this public transit pricing or versus this private pricing, right? Another one is, given the fact that in most cities we subsidize public transit service, then should we also subsidize this integrated service there, right? So there's a lot of a dilemma and debate that could go into this. So I will skip this physical control part. We can intervene, but also I want to mention this part, which is the market structure regulation, right? So in many of the papers we see in the academic arena, including our own labs research, we often just assume that the PTSD will be coordinated, and let's imagine a very nice situation there. But in most practices, what would be the situation where the two specifically competing with each other? So here in this paper, we try to illustrate that in different competition scenarios, for example, this one is to say both are fixed, they're fully regulated, while versus another scenario where the SAV side can adjust its fleet size very quickly, while the PT remains fully regulated, you cannot change. The third one is that the PT size is adjustable in terms of the headway, while SAV is not. And then the fourth one is that they allow both to be adjusted within certain constraint versus the national equilibrium where you have a fully laissez-faire system that is compete on this. So they illustrate what's the consequence of such competition and to what degree the competition will lead to a positive result versus certain situation where this competition will be detrimental to the whole system there. Right. So that's the regulation layer. Now let me also talk a little bit about the technical layer differences there, right? The difference between running a generic autonomous vehicle on-demand services versus a transit-oriented SAV services. The first part is this multimodal network optimization, right? So here you'll find that the optimization have a broader system view here, right? You have to bring the whole transit network design, scheduling, and as well as the SAV services together into the optimization. And then similarly also include this potential for multi-class vehicle optimization. You have trains, buses, van, car, bike, etc. All the system, can you bring this together, right? So here's the simple visual here. We have the transit layer. And before we introduce AVs, there's the walking layer and the public transit layer, right? You consider certain walking access, waiting time, riding time, then you design and optimize this, both the transit network as well as the scheduling process. But now if you introduce the AV as another possibility, either as access egress, or potential sometimes you just send directly door to door, that increase the possible design significantly, right? So that's the kind of network design part of the impact on this. There's also another kind of a more operational strategy differences, right? Let me describe some example. Say in a generic SAV operation, suppose you want to do the ride sharing. Often you will put say maximum detour time in order to guarantee some level of services. But if the SAV service is actually feeding into a train station, then the time constraint is no longer need to be fixed, but rather is timed towards the train headway. So for example, if I have the detour 5 minutes to pick up this passenger, but as long as I can still arrive in the time when before the train arrives for the headway, this 5 minutes detour is irrelevant, right? So as long as both passengers can arrive at the station early enough to catch the train. So therefore, the notion of a time constraint is very different in this integrated SAV service to the train versus the pure SAV alone. Also, it can be flexible on the destination, right? The SAV could decide to send to train station A or B or C. There are many, many possible ways you can design this. The last one, I will also give an example where to really emphasize that there's an asymmetry between first mile service and last mile service. So imagine if you have, say, 20 cars coming to a station, dropping people off, versus there's 20 people come out of the station, you have to pick them up. It turns out that the cost of handshaking between drop off and pickup are very different. It's much easier to drop off the 20 people than to pick up 20 people, because for the driver and the passenger coordinating each other, 20, 50 can quickly generate chaos in the situation, right? And then also how do you organize this SAV as a feeder service? You have either a common origin or a common destination instead of a many-to-many situation. Another notion is about the value of time, about value of information, how they play a role. I'll skip this. Final one on the technical layer is that because the emphasis of equity in the public transit setting, therefore, in all our study, we have to introduce distributional knowledge rather than a point of knowledge there. So in order to do any meaningful equity analysis, you have to understand the whole distributional impact there, right? Last one is the behavior layer. For that to understand from a consumer point of view, how do I really perceive this integrated service? There are different aspects on this, but for now, maybe I'll just emphasize one thing, which is the different behavior norm. If you observe people using public transit like a bus, you will find that the passenger will have a particular understanding of the bus route, and I'll come here, I have to wait, I have to understand the schedule, versus when you use a private car or in some way taxi, which is that somehow you feel privileged, right? So if the taxi waiting for me, I'm late for 2 minutes, you should wait for me. You're serving me myself. But when you have an integrated system, under what behavior norm people should follow, they get confused, right? So this is a public service, therefore I should behave in a certain way, or this is a private service, so I should behave in a certain way. That's also worth a careful understanding, right? So overall, I try to give a sense of they differ significantly in all these four aspects, and also in order for us to have a meaningful multimodal design, we to cover all these different aspects. Lastly, I should mention that we're working on with US DOT on a project of continue this line of thought of developing the transit-centric smart mobile system while integrating this robust organization, integrating the reinforced learning based control, as well as deep learning based demand prediction to continue this type of research. But thank you. So I will pause here.
Thank you, Jinhua. I think it was a very cool talk. I really loved the diagram you put where you were describing all the things going on between the different stakeholders of this game. Let's open the stage for questions. Again, there are no questions on the document, but I have one. So if you can put up back here, this diagram you had, sure. There was no number, but it was the one with the, all the people involved.
Yeah,
exactly. So my question, it's maybe a bit high level, but essentially, if you think about it, to solve particular problems, or let's say to address optimization of certain of these arrows, all of us are developing some tools, right? And those tools often are not the same ones and often do not agree or are not really modular with each other. What's your take on, shouldn't we building something that does all of these in the same framework? Or maybe said in another way, as a community, shouldn't we focus more on having modular pieces that we can interconnect?
That's a great question, right? So for most of the paper we write in academics, again, including the paper come from our own lab, right? We only focus a tiny corner of this diagram, right? And assuming that there is an existing structure out there, given that structure, we do this very micro level optimization or design, right? I think that's the reality of all this academic writing there, right? For it to be go sharp and focused, we have to choose a particular corner while assuming everything else is designed and ready for us there, right? So for that, I just have two thoughts. One is purely from the methodology point of view, is this realistic to attempt this global societal model here? Right? Is this even realistic, right? Because when we do most of our technical paper focus on narrow scope, the understanding of both the vehicle behavior, system behavior, consumer behavior, I think we have enough knowledge to develop those things when we control the other thing, right? But to bring everything together here, in the 1950s or 60s, when city planning is more ambitious as a discipline, we try to do that. We try to say, oh, we can model everything, we can project, and we failed miserably, right? 6 years later, I mean, are we better? We have a much better data. We have a much better machine learning tools, etc. But is mathematics developing enough to capture the complexity of a society? Or another way to look at it, is our entire social science developed enough to engage with mathematics here, right? I mean, there's a lot of strand of mathematical social science, etc. But I would say in order for us to engage this deep quantitative analytical model to address this type of relationship, we're not mature, right? We're far from getting there, right? So then to your second point, given if that's the case, should we then develop this modular research so that you can plug them in easily together, right? That's, I think, definitely a worthy attempt. Yeah, so far when we write the paper, we really don't care how this paper will be plugged into other people's paper. We don't think about it, right? There's no chief engineer here to say, oh, you do this, I do this, so that you can interface each other, right? That's a very good call for action from our community here.
Exactly, I agree on the second part, because I asked this question because I'm a bit between the robotics and control community and now mobility, and on this side of robotics and control, sometimes we have less interesting questions from the societal point of view, but at least there is a very good practice of having benchmarks or having common standards and these kind of things, which somehow I feel sometimes is missing in the mobility research. But
agree.
That's great.
Yeah, if you look at most of the, say, for example, pure software engineer side, we often have a full deck development thinking here, right? From each module, then all the way to the final user's understanding here. In transportation, I think we have not adopted that type of practice.
Okay, yes. Thank you. Faye, I think you have a question. I saw you put your video on, or is just...
Yeah, so I actually I just want to second your feeling about like a sort of want to bridge the gap from like the robotics control side to like the real world transportation system. Yeah, so myself also sometimes have this sort of confusion. So like what kind of assumption I should put on the like a larger system side or the urban planning side. So for example, a lot of criticize for mobility on demand system approach design is so how could you assume, say, the methodology of MOD system, it will be really accepted or implemented by like the industry side? And if that is the case, then how that integrate to the like entire transportation system of the whole city, considering its connection with, for example, bus routes and maybe some other types of mobility system. Yeah, so so usually my answer is, so I do not assume the industry side will fully accept the algorithm, say considering service fairness or efficiency, right? So because usually if they design the algorithm Uber Lyft, they will just assume I want to maximize my profit instead of considering, say, providing fair service to people at different regions of the cities. So basically, I would like to claim, say, okay, so from academic side, I'm just designing something different. I would like to show the performance of the algorithm in the sense that if we consider fair service from like the large cities perspective, that won't affect the system's efficiency, and in contrast, they will also help to improve the system's efficiency in the sense that reduce the total idle mileage. So that can be a big motivation of, say, also considering from the societal side, say we provide fair service, and meanwhile, this is something sort of like good also for the economic side, also for the profit side, say, because we reduce idle mileage, it can also sort of improve the profit, using the same like maybe level of energy, or even travel the same mileage, but when the idle mileage is reduced, then the mileage with profit is increased, etc. So that is my like way of emphasizing like our methodology of considering the system service does not necessarily say contrast to the industry size mode, or to like the one single system's objective. Yeah, so indeed, I do feel like sometimes if we want to move the question, move the problem definition to also integrate well with the entire system, we have to also consider, see, there may be like a conflict among different stakeholders.
Thank you, Faye. I really like your remark there. A couple of quick response, right? The first one is, I think what we can do is we can at least identify scenarios where the profit-making incentive and the system improvement are aligned with each other, right? So those are the situations that there's no reason not to do that, right? Versus a situation where there is a tension between the two objectives, and then explicitly describe the tension. Then say, society as a whole, what are the mechanisms with which we really address those tensions? Who are in the position to make such decisions when there are conflict issues here, right? So the second one I also mentioned is just give you some personal experience. When we talk to this, we work with the transit agents a lot. We often say that you have so many very low productivity bus lines. You have many areas that people cannot walk and cycle to your train station. Can we engage Uber, Lyft to work with you on this, right? For that, you'll find a very different kind of mentality here, right? Some of them say, oh, let's try, engage, etc. But some of them are really, in a way, very suspicious in this collaboration with Uber and Lyft. Many occasions, they are for good reasons in that, right? So that's the context where the two group of people working together is not just the, so when I first write this first paper, I thought, oh, just a mathematical problem, right? You have two subsystems, instead of max optimize on each other, you just do a global optimization, you can improve it, right? And later to write, that's just such a small piece of the entire story there for them to work together at all on this, yeah. Many of the concerns of the transit agency or the DOT will have is way beyond our own like organization discussion here, right? How do you incorporate it into the scholarship? I think would be a great question there.
Okay, yeah, it's a really nice talk. Yeah, learn a lot. Thank you.
Thanks, Faye.
That's a great discussion here. I don't see any other questions, so unless people from the speaker list have other questions, I think it doesn't seem so. Thank you again, Jinhua. It was great. And also it's a great food for thought now for the only break of this workshop. We have now a 1 hour break. depending on where you're at now, you can use it to eat or to just do something else. I will keep open the Gather Town if in case you want to interact with other people following the workshop. And I will put the link now in the chat for that. See you all in 1 hour. Thank you.